Hi there everyone. Welcome to our YouTube channel. Today in this video, we will learn about Introduction to Automata and Theory of Computability, Languages, Strings, and Finite State Machine. Introduction. We need to ask two questions. That is, what is automata? Automata is an abstract self-propelled computing device which follows a predetermined sequence of operations automatically. That is simply an abstract machine for modeling computations. An automaton with a finite number of states is called as finite state machine. We will discuss this later. Another question is, why study theory of computations? Theory of computation is mainly concerned with the study of how efficiently a problem can be solved. Applications of automata. Theory of computability. Some of the plenty applications are natural language processing, in compilers, lexical analysis, parser generators, circuit modeling, vending machines, communication protocol, video games, security, artificial intelligence, cosmology, financial theory act. Languages and strings. In this, the entire course will revolve around this alphabet, strings, and languages. Alphabet. Alphabet is a finite set of symbols denoted by sigma. Example will be, sigma equals a set containing alphabet, or numbers or any symbols. Strings. String is a finite sequence of symbols that is taken from alphabet set. For example, ICOB is a valid string derived from alphabet set ABC. Languages. Language is a finite or infinite set of strings over a finite set of alphabet sigma. As definition, language is a finite or infinite. So, an example for finite set. This is the way we define a language. L is the language. It is made up of W, which belongs to alphabet set A and B. As you can see, the star over alphabet set, which means any combinations of alphabet set. On the right side, we have definition for language, string of length 2. It is simply like a condition. If string satisfy condition, then it is a valid string, else not valid. So here A, B, B is valid as it is of length 2. Now take an example for infinite set. L is the language, made up of W, which belongs to alphabet set of any combination, with definition of string having a even length. Valid strings are epsilon, A, B, so on. This is infinite, right? Epsilon means a string of length 0. Functions on strings. First, look at length, is defined by the symbol. It gives the length of the string. For example, the length of string ABC is 6, and length of epsilon is 0. Next is frequency. Defined by #C of S. Means number of times C occurs in string S. Look at the example, the number of times A occurred in this string is 3. Next is concatenation, which is adding of two strings, that is written like this, or simply ST. Then move on to replication. Defined as a string raised to some power, more simply a string is repeated with number of its power. That is A to the power 3, here A is repeated 3 times. Last one is reversal function. That is reverse of a string, written as W to the power capital R. For example, ABC to the power R gives CBA. Functions on languages. Consider an alphabet set consisting of B, and L1 will consist of even number of A. And L2 consists of strings with no B. First union of both languages will result in a set, may consists of both even number or string with no B. Second one is intersection of both languages will result in a set, having elements common in both the languages. That is string with even number of A. Third one is difference. The elements in L1 is removed from L2, that means string with no B, and string with odd number of A. Then negation of L1, which is exactly opposite to the L1. That is string with odd number of A. Then we have negation of L2 minus L1. We already know the difference of L2 and L1. Now we apply negation to it. Now it results in a set consisting of string with at least one B or string with even number of A. Next, move on to concatenation. Consider two languages, L1 with cat, dog, bird, and L2 with bone and food. Now the concatenation of both results in cat bone, cat food, dog bone, so on. Note that concatenation on language is associative. Cli* is denoted by this symbol, and this gives infinite set of all possible string of all possible length. Cli+ is nothing but the Cli* by excluding epsilon. Language hierarchy. Till now we discussed about various properties of languages. Now let us see various categories of a language, which we will be learning in this course. First we start with the simplest language, called as regular languages, and this is the hierarchy shows. In the core we have regular language, which is built on FSM, stands for finite state machine. And there are some problem which cannot be solved using FSM, so we use higher level language than regular language, that is context free language, that is built on push down automata or simply PDA. And still some languages or problems which cannot be solved using PDA. We move on to another machine. Those are decidable and semi-decidable languages which can be solved by using LBA or Turing machines. Here Turing machine is the ultimate solution for any given problem. In the upcoming session we will learn how to design a FSM and how to find solution. So that's all for this video. We will continue this in the next video. Thank you.